So that's security. Now we can talk a little bit about efficiency. So remember, even though our intuitive picture is to draw those little arrows, and I think it's nice to think about what's in this box as a family of arrows from which you pick one. You pick your favorite one based on your key. Do remember that ultimately this is a piece of code, and that the code is deciding where the arrows go. So it's taking n, it's taking k, and it's running code to determine what arrow maps to which arrows. So it's really a piece of code. I just like thinking about the arrows because it allows us to play little security games like this. But in reality, it's a piece of code, and hopefully the code is quite fast. So we're actually not going to tell you what the code looks like. You can look it up if you're curious. But what I can tell you is that the code does operations that are very fast on modern computers. It does operations that modern computers like to do. Your computer loves doing things like XOR and shifting bits and looking up values in a table. These are operations that modern computers are really good at doing. So as a result, block ciphers generally run really fast. They don't do any really complicated math where you have to exponentiate something or divide anything. None of that stuff. You just take bits and you shuffle them around, and that creates the arrows that you saw earlier. And in fact, modern CPUs are actually built to specifically be good at block ciphers, because we all know what a block cipher is. Everyone uses a block cipher. So modern CPUs are actually designed to be good at block ciphers. So not only are computers good at this stuff, but we are actually building computers to be good at block ciphers on purpose because everyone uses them so much. So this is a case where we're encouraging users to use block ciphers because they're so fast. You'll never notice the time that it takes to encrypt something, in most cases. So what is the block cipher code? Here's a little bit of a backstory on how it was built. So the block cipher code had to be designed by someone. And actually, in the 2000s and the late 1990s, they had a little competition to see who designed the block cipher, which is kind of cool. A fun fact, I forgot to change this slide from last semester, so I guess this error is here forever. I did not design one of the finalists, but David Wagner, who taught this class last semester, he actually did design one of the finalists. So he was in one of the top 5. He unfortunately was not first place, but top 5 is still pretty good. So that's good for him. But ultimately, something called Reindel was the winner. And what that meant was that now everyone agrees that the Reindel algorithm is the one that you use if you want to encrypt and decrypt messages. So lots of different pieces of code to generate arrows could have gone in those boxes. In a different world, David Wagner would have had the algorithm that we used. But in reality, Reindel was used. But hey, top 5 is still pretty good.